Oh, this is section 3.3, which talks about how to divide polynomials. Now, before we begin dividing polynomials, one of those things is that you're going to figure out with this is that there's two ways of doing it. The first way that we're going to talk about is long division, if I could spell long. But long division, and yes, that is exactly what we learned way back when we were in elementary school, long division. So just to kind of talk you through this a little bit, if I asked you to take 4,329 divided by 3 without a calculator, the first thing that most people would do is they would set up that type of scenario. Now, just to walk you through this, because I know it's been probably a few years since you've actually long divided a number, but what you do is you look at how many times will 3 go into the first number. If it doesn't, then you group the first two numbers together and so on. But for this one, how many times does 3 go into 4 is one time. Then the process is you multiply this together, put it underneath the next one, and then you subtract them. Once you subtract, you drop the next thing down, and you start over. How many times does 3 go into 13? 4 times. 4 times 3 is 12. Subtract it. Drop the next. Start over. How many times does 3 go into 12? It's 4. Drop the next. Goes in there 9. And I have no remainder. So my answer would be, or the quotient would be, 1,443. Now, what if that would have had something? Let's say that it would have been something different. Then what I would have done is, in the elementary days, you would have put like R, whatever it is, for the remainder. Well, for mathematicians and whatnot, R stands for all real numbers. So for us, we don't like to write it like that. If it has a remainder, what we normally would write as, or what we would normally do, is we would write the quotient, whatever the quotient is, the answer, and then plus the remainder over the divisor. And the divisor is the number that's going in. So in this case, it would have been a 3. So let's say that there would have been like a 2 left over down here, even though I know that that's not the case. It would have been plus 2/3. That's the same way as writing a mixed number. That's exactly what we're doing here when we do this. So the only thing that's different now is we're not going to give you just numbers. We're going to have letters involved also. So the problem is going to look like this. It's going to say 6x squared minus 26x plus 12 divided by x minus 4, and it's going to say express it, or divide. That's all it's going to ask you to do. The x minus 4 goes on the outside. The 6x squared minus 26x plus 12 goes underneath that division symbol. Now, the one thing that's important that you should probably get in the habit of doing is, if you're missing a term, and what I mean by that is the highest exponent in this case was x squared. The next one was x, and the next one's the constant. If it would have been like x to the 5th, then x to the 4th, and then x squared, we were missing an x to the 3rd term. We put a 0 and then that number in its place, or that exponent in its place, because if you don't have something there for it, you're going to be missing it, and then you're going to get lost. So anytime, and I'll give you one like that here in just a second, where we're missing a piece, let's throw a number in there just to hold its place. So I'm going to do the same kind of concept that I did in the last one. I'm going to ask you, how many times does x go into 6x squared? And what I'm basically saying is, what times x gives me 6x squared? And the answer is 6x. Once I have this, remember, it was multiplied to this. Now, when you multiply it to a thing that's a binomial, which means two terms, you have to do it to both things. So, for instance, I'm going to get 6x squared when I multiply it 6x times the x, but I'm also going to get minus 24x, and I put it underneath the piece that it matches. Now, in the last one, we just subtracted, and a lot of people screw that up. if I subtract or put a subtraction symbol out here, a lot of people get the first one right. That's 0x squared, or this just goes away. But they forget to do all the way over to here, negative 26 minus a negative 24. So me personally, what I do in my head is I will say, draw my line, switch my signs, and then go straight down. That will cancel this and give me negative 2x, and then I don't have to worry about whether I subtract it or not. I drop the next thing, and I start over. What times x gives me negative 2x is negative 2. I multiply that to both pieces, negative 2x, 8, draw my line, switch my signs, add straight down, these go away, and 12 minus 8 is 4. So my quotient is 6x minus 2, sorry about that, and then the remainder is plus 4 over x minus 4. And now I have my answer. So again, it was nothing more than long division. Okay, this long division stuff that you've been doing since elementary school. You've been doing this, but it's still the same thing, just now I have letters involved. I'm going to give you another one. I'm going to set it up already for you so that way you don't have to think about what goes in the inside and what goes in the outside. Now the dividend that's on the inside is 8x to the fourth, and then it says 6x squared. I'm missing an x to the third term. So what I do is I put 0x to the third in its place. The reason why I'm doing that is so that way when we get an x to the third term, we have a place for it to go. It's kind of like me holding the spot or reserving the spot. Like if one of my kids were coming and meeting me somewhere, I would say, hey, I'm holding that spot for them. You know, that's what we're doing there. We're just holding the place for them. You can also do that out here if you need to hold a place for something out there too. So it doesn't have to be just for the dividend. It could also be in the divisor also. Just so that way you have a space or a place for all of it. So the first thing I'm going to do is ask what times 2x squared gives me 8x to the fourth. It's 4x squared. Oops, pen didn't work there. Now I multiply that to every piece. I get 8x to the fourth minus 4x to the third. This is where right here, this one right there would have gave me an x to the third. If I wouldn't have left room for it, I would have nowhere for it to go. And then plus 8x squared. I draw my line, I switch my signs, and I go straight down. The front ones, if you do it right, should always cancel. 0 plus 4 is 4. 6 minus 8 is negative 2. Drop the next, start over. What times 2x squared gives me 4x to the third is 2x. When I multiply that out, 4x to the third minus 2x squared plus 4x. Draw my line, switch my signs, add straight down. This goes away, that goes away, and I get minus 7x. And I drop the next. Now, me personally, I call that a 2 for 1. You know, like a sale. When you get 2 for the price of 1, that's just bonus. It makes it go faster. Most times we just continue to go with this. Now, the thing that I want you to notice with this is that this here is squared and the remainder is just an x. I cannot make the divisor go lower than what's left over. I cannot make it go from a squared to an x. If they were the same, I could do it, but if the remainder right there, exponent, is lower than the divisors, I'm done. That whole thing's my remainder. So my answer is 4x squared plus 2x plus negative 7x plus 1 all over 2x squared minus x plus 2. And it's important also to note this. If you notice when I just put the remainder, I put whatever the number is. If it's positive or negative, I just still put the positive or negative on the top. And then from there, I will always put a plus sign in front of it. if you put a negative sign in front of it, a lot of times, especially if it's a binomial, people will forget that that negative went for both of them, not just one of them, and they end up getting it wrong. So me personally, I always put plus and then whatever the remainder is at the top, and not have to worry about signs then. But long division is a technique that works for all of these. Every single one that we did, and every single one of the ones that is in this section, long division will work for every single one. There is another alternative to dividing than long division, but again, long division works for all. This method that I'm going to show you now only works for some. For example, the previous one to this problem, the one that had 2x squared in the divisor, it does not work. This is known, or going to be known as, synthetic division. Synthetic division only works if the divisor, this thing in the box, is linear. Only if divisor is linear. And what I mean by linear is, look at the exponent. What's the highest exponent? On the x, it should be 1 and nothing higher. If it's higher, you have to long divide. If it's lower, or if it is 1, then you can synthetic divide. In order to synthetic divide, what you do is you take that piece and set it equal to 0. And then that number, 3, is going to go in a, I call it a backwards L. Then I'm going to make a line. So if this is lines on a paper, this is one line, this is 2 lines. Now across that same line with the 3, I'm going to put all the coefficients in order from their degrees down to the constant. So the 2 is going to go in the front, then -7, then 0. Where did the 0 come from? It came from the x term that was missing. Okay, there was a missing piece. We need to make sure that we account for all pieces. That's what we meant by when we put that cubed in there when it didn't have it. We put it in there so that way we have a space for it to go. If we don't, it's going to be wrong. Okay, so also one thing, if you notice, the spacing. Make sure you space these out a little bit so that you don't get them too tight. You get them too tight, then one number actually looks like, or 2 numbers might look like one number combined and so on, and you don't want to do that. So make sure that you space your numbers out accordingly so that you have some room. Now, the method, the way this works is the first number gets dropped straight down. So that's the number 2 goes straight down to the bottom. Then you're going to take whatever number's in the backwards L and you're going to multiply it by whatever number is up. The 2 is up, so 3 times 2, and you're going to insert it underneath the next one, and then you're going to add straight down. So 3 times 2 gave me 6, and -7 plus 6 is -1. And then you start over. 3 times -1 is -3. Go straight down. -3 times 3 is -9. Go straight down. And now I've actually divided. Now what happens is, since you divided by a linear, if you divided it had something like x to the third on top of something with an x, what happens is that 3, you can take 1 away from it, so that way you'd start with x squared. So this would be 2x squared minus 1x minus 3 plus -4 over x minus 3. Again, with the remainder, I always put plus and then the minus. If it's a negative, I just put the negative upstairs with it. And all I did again was I took the highest degree and decreased it by 1 because we're dividing it by something linear, and just canceled or brought one down all the way to the end. This is synthetic division. This type of division, this stuff right here, is going to be something that we are going to use over the next this section plus the next 2 sections exclusively. We are going to use this a ton. One of the guys that I went to grad school with, he actually was opposed to it and said, no way, I'm going to long divide. And he wasn't around much longer after that, so needless to say, he just couldn't figure it out. And that, to me, I mean, that takes a lot of time with long division. This will go really, really quickly. I'm going to show you another one here. just to show you again how it works. Try to find one where I got a missing piece. Here we go. X to the third minus 8x plus 2 divided by x plus 3. So the first thing is I'm going to take the divisor and I'm going to set it equal to 0 and solve for x. So the number that's going in my backwards L should be negative 3. And then across that should be a 1, a 0, a negative 8, and a 2. 1, 0 because there wasn't an x squared, negative 8, 2. Okay, so that's how that went. Drop the first one, multiply, insert it, add. Multiply, insert it, add. Multiply, insert it, add. So then again, because it started with x to the third, this starts with x squared minus 3x plus 1 plus negative 1 divided by x plus 3. And I'm done. Now, one thing with this that I haven't talked about yet, but if you are interested in it, if you want to check these, something that some people like to do, if you like to check things to make sure that everything worked out, what you do is you take the divisor and you multiply it by the dividend, or the quotient, and then you add the remainder. If you do that right, if you do this step right here, you should get this one right here. You should get x to the third minus 8x plus 2. If you don't, you messed up. But you should get it for that problem. Okay? Now, from there, you're going to find or use what they call the remainder theorem. If someone ever asked you or gave you this polynomial where they say p of x equals 3x to the fifth plus 5x to the fourth minus 4x to the third plus 7x plus 3, and they said find p of 1. In previous assignments, all you would have done is plug the number 1 in and see what you get, which is not wrong. That's a method of doing it. This method, though, is if they tell you to put 1 in, 1 is going to go in my backwards L, and then across here I have 3, I have 5, I have negative 4, I have 0, I have 7, and I have 3. Okay? So what I'm going to do here is I'm actually going to synthetic divide. I'm going to show you what happens. Drop the 3, multiply, insert, add. Multiply, insert, add. Multiply, insert, add. Multiply, insert, add. And 14 is what I got. Now, if I put in 1, like most people would do if I were to give them something like that, and for the x, 1 to the fifth is 1 times 3 is 3. 1 to the fourth is 1 times 5 is 5. 1 to the third is 1 times negative 4 plus 7 plus 3. 8 minus 4 is 4 plus 11, or 7 is 11 plus 3 is 14. Notice this number here and this number here are the same. That's supposed to be like that. The remainder theorem states that the remainder is the value of the polynomial that you want to try to find. So just to give you another one, a lot of times what they'll do is they'll give you it this way instead. They'll say p of x equals 4x squared plus 12x plus 5, and it'll say c equals negative 1. So when it gives you the c equals like that, it's already telling you what number to put in. You do not need to switch it around. That is the number that you put into the backwards L. Notice there was no missing spaces, so I didn't have to include 0 anywhere in there. I dropped the 4, I multiply it, insert it, add, multiply, insert, add, and I got the final answer of negative 3. I would have got the same thing had I plugged in negative 1 into my formula. Okay, so that's the remainder theorem. After that, the last thing that they're going to ask you to do is finding the polynomial with specified degrees, or with the zeros. Okay? And they're going to give you a degree. And I'll say something like degree, we'll go to the short one first, 3. And it'll say zeros, -1, 1, 3. And what it's asking you to do is, okay, I'm giving you the degree, I'm giving you all the answers. I want you to come up with the polynomial that it started with. I want the beginner. I don't want the answers. I want to know what did it start with. So the first thing in order to get at something like that is it would have been x equals 1, x equals -1, and x equals 3. Before it would have got to that stage, it would have been x plus 1 equals 0, x minus 1 equals 0, x minus 3 equals 0. And before it would have got to that stage, it would have been everything all multiplied together. And this is where your multiplication skills or distributing skills will come into play. You are going to distribute. You are going to FOIL. You're going to, whatever you want to call it. But be careful not to go everything all at one time. It's just the first two first. So x squared minus x plus 1x minus 1. Simplify that first, and then we multiply it by the third one. X squared minus 1 times x minus 3. So we get x to the third minus 3x squared minus x plus 3. And again, I just FOILed it all out. Combine any like terms, which there was none, so therefore I am done. Now that's what if it had 3. If it had 4 of them, then I would suggest do 2 at a time, and then you can bring them together. If it had 5 of them, do 2 at a time, 2 at a time, and then the third one finally. You know, I mean, it's all up to that, or multiplying. It might also give you some stipulations, like make sure the coefficient of x to the third is 4. If it said, and the x to the third term coefficient is 4, then I just simply multiply everything by 4. So I get 4x to the third minus 12x squared minus 4x plus 12. And then I would have my final answer. So if it says anything like that, or if it says the constant needs to be this number, we just multiply it by whatever we need to multiply it by so that it satisfies the given condition. If it doesn't say anything like that, then you don't have to do that step. That's only if it says it. So as far as that goes, you're just going to be multiplying. And that should do it for section 3.